Hi everyone, welcome back to ChemHelp ASAP. In today's video, we are going over a really common lab that you would probably see if you're in, say, your first semester of Gen Chem in college, possibly also taking AP Chemistry. This is just a really common lab. Okay, so let's take a look at this. This is the standardization of a sodium hydroxide solution using titration. Okay, so first we're going to make a 1 liter solution of 0.1 molar sodium hydroxide. Now we can have a lot of nuance here. Do we need to be very precise with our measurements? Do we not need to be precise with our measurements? Well, let's take a look at the rest of these steps here. So you'll notice it says you add about 4 grams. Okay, as soon as they say the word about, I know that we really don't need it to be exactly 4 grams. So that's one place where I can save time. I don't need to make the balance say 4.00 grams. It just needs to be about 4 grams. The second thing I notice is that we're going into a plastic 1 liter bottle, which also tells me that my volume is not super important in this case. We're just trying to get a very rough estimate of about a 0.1 molar solution of sodium hydroxide. If you need a volume to be very precise, you're generally going to be working in glass, with the exception of if you have an automatic pipette, but generally your glassware is going to be much more precise than anything in plastic. So I've got a couple of clues to tell me that this first step can be done pretty quickly and has very little precision to it. The other thing I notice is just some lab technique. They first want me to fill the bottle halfway, and you go, why would you fill the bottle halfway if you need to make a 1 liter solution? Well, you'll notice in the next piece you're going to fill it halfway because you're going to mix until all of the sodium hydroxide is dissolved. So maybe you haven't dissolved sodium hydroxide before. It does dissolve readily in water, but it usually comes in these little pellets, and so shaking the bottle when it's just halfway full is going to give a little more agitation. It's going to help that dissolve faster. So you'll notice not only I can pull things out and say, okay, this 4 grams of sodium hydroxide, very approximate. I don't need to worry about it being precise. And also because I'm in this plastic bottle, I'm just making a solution. It needs to be about 1 liter and we need to have about 4 grams. So we don't need to worry about spending a lot of time making this 0.1 molar solution very precise. Okay, but we do need to make sure also to fill to the top of the bottle once we have dissolved our sodium hydroxide. That is a step that I think students would tend to forget, and then you've got a concentration that's not 0.1, it's going to be way off. Okay, so that is our first part of this procedure. We're just preparing a sodium hydroxide solution. This step should not take us very long. This is a very rough estimate, and I would even say, depending on your lab setup, if you have like a top loading balance and an analytical balance, I would just use a top loading balance for this 4 grams because it needs almost next to no precision at all. Okay, let's look at the second part of this. Okay, so now we're going to standardize the sodium hydroxide solution, which again refers back to the previous one to say that how we made the solution is less important because we're getting ready to standardize it, which means we're getting ready to calculate exactly what our concentration is. Okay, so let's look at the standardization. So we're going to titrate samples of potassium hydrogen phthalate. Now, probably later in the lab, they're just going to refer to this as KHP. It's a lot easier to say, and it's a lot shorter when you're writing a lab report. But keep in mind what KHP actually is, because again, if you're writing a lab report on this, you're not going to want to refer to it as KHP the first time you refer to it. Just like in the lab report, you're going to refer to it as potassium hydrogen phthalate. Okay, so we're titrating this KHP and we're titrating it to a phenolphthalein endpoint. Now, what's important about this is not only does that identify our indicator as phenolphthalein, but also you can see they tell you what the color change is going to be. So this is going to go from colorless to pink. So we know what our goal is here. We want a pink solution. Okay, so that's also really important to just keep in the back of your mind. Okay, and we also need titrations that should agree within 0.003 molar sodium hydroxide. Okay, important thing to notice about units here. We want these titrations to agree within a certain set range of concentration. Now, when you're doing a titration, you're looking at volume. So this is not agreeing within 0.003 milliliters. This is agreeing within 0.003 molar, which means you are going to need to calculate as you go. So as soon as you finish a titration, you're going to need to go ahead and do that calculation and figure out what your concentration of sodium hydroxide is. Because when you do your second titration, you're also going to need to do that calculation and then compare your molarities. Now, one thing I know that students in this type of situation will get messed up on is they think the volumes have to be the same. The volumes do not have to be the same. It's after you've done the calculation that you want to compare the precision. So don't try and compare precision before the calculation, because that's not going to make that much of a difference. You want to look at the precision after the calculation. Okay, so that's important, again, to know. We're going to have to be careful with our titrations, but we really need to do our calculations to see if we're being precise. Okay, our next step of this titration is we're going to weigh out on an analytical balance between 0.6 and 0.8 grams of dry KHP. Okay, so a couple of things pop out at me. First, an analytical balance. That tells me that I need to have at least 4 decimal places in these weights of KHP. The second thing I notice, and again, this lab report puts it in bold, it's got to be dry KHP. So this is a situation where probably the week before, or maybe the day before, you have put this in the oven to dry it, or possibly your professor is going to supply you with dry KHP. But it also tells me that if for some reason I don't have enough right here at the balance, I cannot just go into the stockroom and grab KHP, because that may or may not be dry. So if I'm in a situation where I need more, I need to make sure it's dry KHP and not just KHP that you don't know. Okay, so after that has been weighed out, and notice again, you're getting between a 0.6 and a 0.8 grams. It doesn't matter where it falls in there, but make sure you record all 4 of those decimal places because you are working on an analytical balance. Okay, the next step here is we need to add between 15 and 20 milliliters of distilled water. Okay, between 15 and 20, does it matter what the volume is that I add to this sample before I titrate it? Well, if you think about what your calculation is going to be, when you're calculating your molarity of your sodium hydroxide, you need to know your moles of KHP. Does the volume affect that? No, you're actually going to start with your mass of KHP to calculate your moles of KHP. So your volume here doesn't matter. If you've got like a wash bottle, a squeeze bottle, just make sure you add about 15 to 20 milliliters. It does not need to be recorded. It does not need to be precise. Again, this is another place where you can save time by not trying to be really precise with a volume that doesn't need to be precise. Okay, the other little tip in this section is they say you may gently heat the solution to help dissolve the KHP. Okay, so this tells me not only do I have the option to heat the solution, but that the KHP may be a little bit difficult to dissolve, and I need to make sure that it is completely dissolved before I start the titration. Okay, so after the KHP is dissolved, then we're going to add our 3 drops of phenolphthalein indicator. Again, remembering what they said before, your transition is going to be colorless to pink. So when you add this phenolphthalein, it should not have a color to the solution. So if you add your phenolphthalein and you get a color, something has gone wrong. So again, keeping that color change in mind is going to be really helpful here. Also, 3 drops, you do not need to add a lot of indicator. Okay, then they say, yes, your KHP sample is now ready to titrate. Okay, so next step. So we're going to prepare our burette for our sodium hydroxide solution. All right, so first thing, a burette. If you are familiar with the burette, that's fine. You can just move on. If you are unfamiliar with what a burette is, make sure you look that up. Either just look up a picture of what a burette is or go to a video showing a burette so you know what it looks like, so that when you're in lab, you can say, oh, here's my burette. I know what this looks like, instead of going, wait, what is a burette and what does it look like and what piece of equipment do I need to use? Okay, so we're going to prepare our burette, and you notice you'll say, first rinse the burette with 2 portions of your sodium hydroxide solution. Okay, so this is really important to do, is you don't just want to use a dry burette. You're going to first rinse it with, again, that sodium hydroxide solution that you made at the very, very beginning of lab. You've got a liter of it, you've got tons of it, you've got plenty of it. So remember, like, this step is one that's easily forgotten because you think, oh, I'm just going to put it in the burette and we're all going to be set. But remember, you need to rinse it. And again, you might be thinking, this is well, very often a question at the end of lab, why did you rinse the burette? Well, you want to make sure that the sodium hydroxide in the burette is actually the concentration that you have. So if you've got a burette that has a contaminant, or maybe it's just been washed and it's a little bit wet, that's going to change your concentration of sodium hydroxide in that glassware. So that's why we rinse it. Okay, and then once we've rinsed, then we're ready to fill with our sodium hydroxide solution. So one thing I just, when you're rinsing your burette, very often what's happening is maybe a lab has been run right before your lab, and so they're anticipating that those burettes have been cleaned, but they're still wet, which is again why rinsing is really important. Okay, next step. Before you start a titration, make sure the tip of the burette is filled and it has no air bubbles. Okay, so why? This is a place where I think it would be very helpful to actually watch a video. So especially if you haven't done a titration or you haven't worked with burettes at all, watch a video on how you do a titration or how you fill a burette, and that will show you what they're talking about. What does it mean that the tip of the burette is filled? And it will show you like, okay, well, there's going to be an air bubble where. So a lot of times when students are unfamiliar with burettes, they might look for the air bubble at the very top of the burette. That doesn't matter. That's totally fine. We're talking about air bubbles, usually down close to the stopcock. So this is where it's really important to know what the lab is talking about before you get into lab. Otherwise, you're going to get into lab, you're not going to know what's going to happen, and you're going to spend a lot of time floundering around like, well, what is this and what is it supposed to look like? And did I do it right? Did I not do it right? And even worse, if you're actually titrating and your tip is not full and you have air bubbles, then you're getting wrong volumes, which means your concentrations are also wrong. So this is a place where you want to prepare before lab. Again, watch a video. I think the videos, like YouTube has tons of videos. Go watch a video on a simple titration and it'll show you how to make sure your tip is filled and how to make sure you have no air bubbles. Okay, the other thing they say to do is make sure the burette is not dripping or leaking in any way. Again, that's something that if you watch a video beforehand is really going to be very helpful. Okay, the next part. Each KHP sample should take between 30 and 40 milliliters of sodium hydroxide to titrate. Why did they not give us an exact number of milliliters? Because remember, you're weighing out your own dry KHP, and that's going to have a unique amount of milliliters of sodium hydroxide to titrate. So they're just giving you a range here of what to expect. The other thing I say is you do not have to fill your burette to the 0.00 milliliter mark exactly each time you titrate. You just need to record your starting and ending volume. And this is, again, this is a time-saving tip. So you don't have to painstakingly, with a lot of time, always fill back to that 0.00 mark. You just have to record where you started and where you finished. Now, with most burettes, they're going to be 50 milliliter burettes. So you will need to fill up most of the way to the top, but again, you don't have to fill up to the top. You definitely don't want to overfill it, but you don't have to start at 0.00. You can start at 5.25 if you want. Just so long as you record that starting volume and record your ending volume, that's all that matters. Okay. So, and the next step says, remember to read your burette to 2 decimal places. This is really important, again, to know your glassware. Burettes, we always record to 2 decimal places. Graduated cylinders go to 1 decimal place. Volumetric pipettes go to 2 decimal places. Volumetric flasks also go to 2 decimal places. So again, be familiar with the glassware before you go into lab, and then this becomes very easy and you don't have to look it up or ask questions or waste time. You know exactly what to do. Okay, and then they say titrate each KHP sample until a faint pink color persists in the Erlenmeyer flask. And it says you may need to split drops close to the endpoint. Okay, let's talk about the first part first. We're going to titrate until a faint pink color persists. Okay, so what does that mean? What is faint pink? This is where, again, watching a video is going to be really helpful. How faint a pink do you need, and what does it mean that it persists? So what you're going to find, again, if you watch a video and you haven't done this before, is that as you add the sodium hydroxide, you're going to see a little bit of pink. But as soon as you swirl your Erlenmeyer flask, that pink is going to go away and your solution goes back to colorless. So that's the persisting part here. Again, this is where a video is really helpful to watch. And that faint pink, again, a video is going to show you what you mean by faint pink. Just word to the wise, put a white piece of paper underneath and you can see that faint pink. And then it says also you may need to split drops close to the endpoint. Again, you might say, well, how do you split a drop? Like, what is this? This is where a video is going to be really helpful. Look up a video. How do you split a drop close to the endpoint? And you can see exactly how that's done. So again, when you're in lab and if you need to split that drop, you're ready to split that drop. Now, the last step says if you overshoot the endpoint, that titration should be thrown out. This is very hard for students to do. If you spent a long time doing this titration, you really don't want to throw it out. But if you've overshot the endpoint, again, your solution is not a faint pink, but a hot pink, you need to be willing to throw that out and start over. Otherwise, your data is not going to fit within that 0.003 molar precision there. And they give another hint, a hint to know roughly where the endpoint is to do a quick calculation, assuming your sodium hydroxide is 0.1. And once you get close to that value, slow down. All right, so again, they told us that these are going to take between 30 and 40 milliliters to titrate. You don't want to be dripping very slowly at between 0 and 10 milliliters. You know it's going to be more than 10 milliliters. So this is where you save time. You do a very quick calculation. So you assume your concentration is 0.1. You figure out, okay, I have this many grams of KHP. How many milliliters of my sodium hydroxide will it take? Let's say you assume it's going to take 35 milliliters. Okay, you don't want to spend a lot of time going from 0 to 25 milliliters. That's just time wasted. You know the endpoint is not there. So you want to go very fast through those initial milliliters, and then as you get closer, that's when you want to slow down. That's when you want to start maybe adding drop-wise or a couple of drops, again, just depending on how close you are. And then, you know, when you're very close, then you're ready to split your drops. But I see a lot of students making the burette drip very slowly from the very beginning. It's going to take you forever to get to that titration endpoint. Go fast at first. Go slow at the end. If you go slow the whole way, it's going to take a very, very long time for you to get your titration done. So this would be, if you're doing AP chemistry, this might be your whole lab. If you're doing Gen Chem in college, this would probably be like part A of a longer lab because you have more time in the classroom to do this. But this is how I would read through a lab. Make note of any new glassware that you need, and you can watch a video on what the glassware looks like. How do you handle it? What is it used for? Look at any new techniques that you are unfamiliar with. Like if you don't know what splitting a drop is, that's something you're going to want to look up before you get into lab. And the more you know before in lab, and the more you can think through, this is how the lab is going to go, the more efficient you're going to be with your time, and also the better data you're going to get because you already have an idea of what needs to happen in this lab. I hope you found this video helpful, and thanks so much for watching.